Hello everyone, my name is Sudan Sundar. I'm studying in degree again in final year. So my roll number is 4164 and URN number is 23031005. Today, today for an video presentation and nice activity of this distributed cloud computing, I have a topic that is design goals and the Boolean reaction algorithm. So how it works, let's see. First, we will see an agenda, what we are going to study. First is design goals of distributed system. We will take a look what exactly is design goal of distributed system. Next will be why coordination needs leader. So why do we need a leader in a coordination? Next part will be the Boolean algorithm, the main concept of our presentation. Next is the work example. We will demonstrate it using an example. And next will be the trade-offs and the takeaways. So let's see the distributed system design goals. So the distributed system has basically 6 design goals. It is divided into 6 roles that are here. First is the resource sharing. So what is resource sharing? Resource sharing means the distributed system shares the resource for using the software. So it has hardware, data, and service on one node and usable by others on the network. Next is the openness. So basically, distributed system is open for all, is openly used, and it can be used by anyone. Next is the scalability. It has a good scalability. It can be scaled to meet much extent and can be used for that. Next is the fault tolerance. Means the system keeps operating correctly despite partially hardware or a process failure. Next is the transparency. So the transparency means distribution is hidden. System looks like single coherent whole to user. And last one is a concurrency. Concurrency means multiple processes run and shared resource at the same time safely. Means it is quite similar to the resource sharing, but multiple processes can use a single resource concurrently. Next is why distributed systems needs a coordinator. Means why distributed systems needs a leader. So basically, we can consider an example. For demonstrating a project or if we are going to build a project, we do need a leader. So what is the role of leader? The role of leader is to assign a task. Means the role of leader is to assign a task to each and every team member, and there should not be any partiality in assigning a role or a task to a team member. So what is the leader roles? Let's see. Uh, here is the Here is a distributed system. Why do we need distributed system leader for that? Main coordination tasks, assigning work, sequence updates, managing logs are easiest uh, with one process acting as a coordinator. So the one process will act as a coordinator, and the roles will be assigned by the coordinator to each every other process. So how it works? Any process may fail at any time, including coordinator itself. Then a system must detect a failure and fix the replacement automatically. The system is capable to uh, detect a failure and uh, pick a replacement for that particular process. Automatically. The process of choosing a new coordinator is called a leader election, and the Boolean algorithm is one of the classic solutions which is called. So let's take a look what Boolean algorithm is. So the Boolean algorithm proposed by the Hector Garcia Molina in 1982, the process with the highest ID always become a coordinator. Means the process which is having a highest ID. Highest ID means the process has a unique comparable ID. Example process number will be the leader, means will be the coordinator of all the processes. Every process knows the IDs of all other processes. This is the main funda behind it. Next is a process can't reach a crashed process, but not vice versa. The process can't reach the crash process, but the crash processes can reach to the process. Communication is reliable, means messages arrives intent and in order. Next, the process can initiate an electron if it suspects a coordinator has failed. Consider this, there are three message types. First, three message types. First is the election, and then OK and answer, then a coordinator. If there is the election, send to the process with a higher ID to the start, propagate in election. Mix with the reply confirmation. I'm alive and I outrank you. Step back. And the broadcast by the winner to announce it in a new lead. Then how election runs. Basically the election runs in four different steps. The first step is detect and initiate. And the another step is wait for the response. Another one is step aside, and the last one is announce the winner. So what is detect and initiate? So basically the process P notices the coordinator in, uh, is down and starts an election by sending election message to every process with a higher ID. If no one with a higher ID replies within a pass out wins. P wins and P becomes a coordinator and broadcast coordinator to all. Means, if P has sent a message, election message to each and every process, if no reply is there within a fixed time, then P becomes a coordinator and P initiates, that means P sends a message to all other processes that the P has become a coordinator. If the higher the process replies okay, if P stops, that process takes over its own election and repeating the process upgrade. Means if any other process replies that with a higher ID, then that process then the P stops first and the other process becomes a leader. Then another one is the announcing winner. So the one the process which has uh, has been announced as the winner of the election. Next is the worked example. So P2 sends the election to P3, P4, P5. P5 is down, no reply. P3 and P4 reply okay. P2 steps aside. P3 sends election to P4. P4 replies okay. P3 steps aside. P4 sends election to P5. No reply. P4 wins by default. P4 broadcast coordinator to P1, P2, and P3. Means here P4 becomes the leader and the election has won by election is won by the people and the winner has been announced as P4. So here's the last slide. What we have done, we have got listed trade-offs and takeaways. So the strengths of this Bully algorithm are simple to understand and implement, guarantees termination with a well-defined winner, works well when failure are infrequent. Then the limitations are high message overhead means it has high message overhead means it has the delay of a time complexity, that is big often square message in the worst case. Assumes reliable communication and non-process IDs. Frequent failure triggers repeated cost selection. So good lines are distributed system uh, design goals, transparency, scalability, failure tolerance, and rest. Set So this was all about the process and then from my side, thank you.